Welcome back to Unusual GCSE Questions, and this question is from Edexcel Higher November 2021, paper 3, and it's question 23, and I'll just put it up on the screen now for you to have a look at. Right, I'm on my own today because Grace is not at school at the moment because she's having a baby, so it's very sad, but we're going to have to, it's either this or nothing, isn't it? I'm going to have to cope. So let's see how it goes. This is a hard question. A lot of students just get totally confused by this, so I thought it was particularly interesting. It's about a triangle, ABC, and they've drawn a line from A to this point they've called D, such that these angles are the same. Notice that those angles being the same doesn't mean that these lengths are the same. That's not the midpoint. So that's something to notice. So how are we going to prove that AB over BD is equal to AC over DC? How are we going to do that? If we're going to set up an equation, we're going to prove an equation, we need to find two things that are equal and put them equal to each other. So we need to look at the diagram and say, what things are equal to each other? Now, someone suggested to me that maybe this line AD is common to both of these triangles. So if we can set up an equation and make AD the subject to do with this triangle, and set up an equation to do with this triangle and make AD the subject, we could put the right-hand sides, let's say, equal to each other. But there's a more obvious thing, isn't there, in this diagram? A more obvious thing that's equal to each other, which is the two angles that they have specifically said are equal to each other. Now we want to use AB, BD, AC and DC. So we want to use all four parts of the sides of the triangle. So what can we do? Well, we could use the sine law, couldn't we? We could use the sine law and say that sine x over BD is equal to, I want to use AB, so let's use this angle here, let's call that angle A, equals to sine A over AB. That's one equation. Okay. It's important to remember that at this stage, you don't have to know exactly how you're going to do this question. You just got to get started so you can start picking up some marks. Let's do the same thing using the other triangle. Let's call this angle B. And we've got sine x over DC. That's equal to sine B over AC. Okay, now what's nice about this is that all the four lengths that we need to have in our equation that we're trying to prove, they're all in here now. Now if I rearrange both of these so that sine x is the subject, got that. I've got that. Now, if sine x equals this and sine x equals this, then these two things must be equal because they're both equal to sine x. So let's do that. What have we done? Over sine A times sine A equals DC over AC sine B. Okay, this is looking a little bit like this, isn't it? Except the fractions are upside down, and we've got these things in here. Right, now at this point, an interesting thing happens in the question. Now, I don't know whether you know this, but the thing about A and B is that they add up to 180. And if you've got two angles that add up to 180, the sine of those angles is the same. This is something that you should know from the trigonometry work that you've done. So if I sketch the first part of a sine graph, so if I've got an angle here, its sine is whatever this value is here. If I subtract this from 180, because the sine graph is symmetrical, 180 minus this has the same sine value. And that's just something that you could do with knowing. So let's say but we know sine A equals sine B because A plus B equals 180 degrees. And so if sine A is equal to sine B, we can divide both sides by the same thing. It just happens to be written in a different form. And then if we have a fraction equal to a fraction, something else that hopefully you know is that you can turn those two fractions over and they'll still be equal. So we could write, therefore, AB over BD equals AC over DC. And we're done. So that is quite an interesting question for GCSE. If you've got any comments about that, if you would do something slightly different, or there's anything in there that you don't quite understand and you want me to say a bit more about, leave a question in the comments and I'll reply to all of them. But I think that's the best way of doing that. So I'll be back next time with another hard question.